this idea of variables is really important. The fact that we can store data and access it and use it later. And what you'll see in some of our other examples is that we'll be able to store a number of variables, like a user's name, and we could customize a script. Say like, hey, Jason, how are you? And use this over and over and over and over again. Once you kind of store a value into a variable and you hold on to it, you can use it for any number of reasons in a script over and over and over again. And this idea of variables in bash scripting exists on multiple levels. So one of the other things that we're used to do in a script, or used to doing in a script, is basically having or passing options into our script. So let's take a look at what this script does. Right now you see that there's $at. And this looks a little bit like $ curly bracket output curly bracket. So let's see what this does. We're going to jump out of here and look at the next line of our script. Clear this and just go ahead and run it. And notice that it says I saw, and there's a space. There's nothing in there. And you say, well, that's weird. Why? What's there? But what if I were to pass in an option or something to the script? Well, now notice that when I ran my script, I put in a space and the word option. And notice that when it printed out, it printed the word option. What happens if I do multiple options? Notice now it prints out option 1 and option 2 in that space. So initially I had no options passed into my script, nothing printed. I added one option into my script, or the word option, and the word option printed. You know, I can pass anything into the script. I'll put Jason is awesome. And notice that whatever I pass into the script prints out on this line. So how does that work? Well, let's jump back into our script and take a look. And I'm just going to use the up arrow to get to this. If I scroll down and look at this, you'll notice that $at is actually a variable. And what it does is it contains every string or everything that you enter after the name of the script on the command line. It's a really easy way to access components on the command line. So we could use this for things like getting the name of a file or the name of a directory or the name of a user via the command line. So we could easily grab that information. A couple other things that are important to note is that notice that $at grabbed everything after the name of the script. If I want, I can just do $1. Now if we run this script, what I'll do is go back up and run it with nothing. So I get a space. Go up again and run it with just, let's just run it with my name. So now it says I saw Jason on the command line. And now let's do Jason is awesome. Notice it still only prints Jason. And that's because when instead of using $at, if I use $1, $1 is going to give me the first option after the name of the script. If I use $2, it would give me the second option after the script. And $3 would give me the last option after the script. There was a really weird thing going on with this variable, $at, $1. In the previous example, we looked at this $curly bracket output, and here I didn't use that process. So the question is, can I put a curly bracket in there, and will this still work? So let's do $1. In fact, let's do $at, because that's one I actually should work, but I don't know. So if I run the script now and pass in Jason is awesome, notice that it still works. So again, one of the things that we can deal with in terms of bash syntax is that there's a couple of different ways to write things. But even though I didn't initially have this in my sample, I really like this $curly bracket syntax because it makes it really obvious that what you're looking at is a variable, that you're trying to read data out of there. And by the way, again, this is a special named storage location, and $1 is a special named storage location, right? And where do those things come from? Well, when you run the script, anything on the command line is automatically put into a storage location called $at, and each individual item is accessible via $1, $2. So these are some storage locations that are built automatically for you. All right, next up. If we can say things to the user on the command line, and we can store values into a variable, then it would make sense that we could actually go ahead and do some fun stuff that look more programmatic. So in this case, what I'm going to do is I'm going to echo out a response to the user. I'm going to build a more interactive shell script. I'm going to say, hey, go ahead and enter a value. And then what I'm going to do is I want to read a value in from the user, like their name. So in the previous example, we looked at a way that we could have a user enter something like their name behind the shell script at the time they execute it. But let's say we want our script to be more interactive, more friendly. So what we can do is we can use echo enter a value, and there's this Unix command line utility called read, which will basically stop the script's execution, wait for the person running the script to type something in, and when they type it in, it'll store it in the variable name that you give here. So I have a storage location, right? Again, like a bucket or a shoebox named user input, and the script will stop running, and I'll be able to store the value the user entered here into this location. And then when I'm done, I'm going to go ahead and use another echo and just kind of print that back out to the user. We'll see a little bit more useful version of this in the next script example. So let's run this and see how it works. So we run my script, get rid of those commands because we don't need them, or options to the command, we don't need them, and let's see what happens. It says enter a value, and notice I don't have a prompt here, I just have a blinking cursor. So I'm going to enter JSON and hit enter, and it says I just entered JSON. If I run it again, anything I enter there, this is, and let's put a space in there, is awesome. Notice that it grabs everything that the read command handled. And the read command is actually a command. Well, it actually is built into this shell though. So you'll notice that when you man read, it's just a way for this shell to block and grab some information. So anyway, this is really useful. Let's see how we can use this in a script that does something kind of more interesting than just prompts the user and tells them to have a good day. So let's comment that out, and let's go down to the next line. So what I'm going to do now is I'm going to utilize the same exact feature as the previous script. I'm going to ask the user to enter a file extension. And then what I'm going to do is let them enter that file extension, and then I'm going to use it to create a new file that has that file extension. This is really powerful because we could use this, or we could use the previous enter something at a command line to build customized scripts where we could actually go ahead and use input from a user, or either it be entered as an option on the command line or entered interactively at the shell to make our scripts a little bit more robust. So let's run this and see what happens. So what I'm going to do is run this again, and it's going to ask me for an extension. I'm going to call it JSON, and then if I do an ls, you'll notice it created a file called yourfile.json. It took my input and it created a string with your file and .json. So pretty awesome that we can use this process to do some really interesting kind of interactive things. All right, next up. And then we'll kind of end with like one additional item. So in this case, sometimes, right, everything we've done so far is really just basic data processing into our scripts. And so what I would like to do is have my script do some basic logic, basically do some thinking for me. And so just like in most programming languages, Bash scripting supports selection statements. So this idea that it can make decisions, or otherwise known as if-else statements. And essentially what happens is you have this weird looking construct called if, else, and phi. And at this point, if you've never done any program, I usually just tell students to go ahead and copy this directly. And basically what happens is you have this construct called if, and what happens is it checks everything between this set of hard brackets to see if that value is true or false. If the value or the test in here is true, it goes ahead and executes everything right after the then statement. If the value inside of this set of brackets is false, it goes ahead and executes the items here. So this would be like, hey, if a file exists, don't overwrite it. Or if the file exists, email the user and tell them there's a problem, or shut the system down, or something like that. So in this case, what I'm doing is I'm going to determine if this file is there. The -d here basically says, does this item exist, and is it a directory? So /etc/sysconfig on the system, we'll see if it's there, we'll see if it's a directory. If this exists and it is a directory, then it will print that file is there and a directory. If it exists and it's a regular file, it'll say it's not there or not a directory, or if it's just not there at all, it will not work. One of the things to point out in this contract too is notice it starts with if but ends with fi. It's a little tricky. So let's go ahead and run this program and see what we get. So we're going to run bash snippets one more time, and it says it's not there or not a directory. So if we look at Etsy, notice that if I tab out, there is no file called sysconfig, but there is a file called systemd. So let's go in and edit our file so we can see if that file exists. In fact, let's modify our script so we can make this a little easier. What I'm going to do is make this so that I can pass the value into the command line. So what I'm going to say is, when I run the script, I'm going to pass in a directory that'll get stored into $1, and I'll be able to say, hey, is there a file that exists at that path and is it a directory? So in other words, is there a directory that exists at that path? So now I can combine some concepts that we talked about previously, and we can see how this works. So this idea, like, if you've never done any programming, oops, notice that I get no file there because I didn't pass in a parameter. But the idea here is if you've never done any programming, that you can kind of start to put together these scripts just by kind of treat it like a menu or a recipe of different ideas that you can start to mix and mash together to get the results that you want. And notice this time it says, hey, that file is there and a directory. Why? Because I entered Etsy systemd. It's a file that exists on the system, and that it's actually a directory, not just a file. And I passed that into the script as an option. It was stored into the $1 variable and utilized in that if statement to make that decision. In my previous example, you noticed I used -d within the if statement to see if a specific item in the file system was existed and was a directory. And you might be thinking, where do I find these, all the different options that I have? Well, right now I'm looking at the man page for bash, which is really, really long. In fact, you'll notice that I'm actually on line 2431 in this file. You can actually Google to look at like bash if statement conditional expressions. But if you ever want to look in the man page, it is there. You just got to really, really dig down for it. And so what you'll notice is that -d is what I used. It returns true if a file exists and is a directory. There's also -a, which is true if a file exists. -b, true if a file exists and is a block special file, if you want to see if something is a character special file. -e, just true if a file exists. Doesn't really matter that it's a directory or a file or anything else. That's just that there's something there with that name. -f, true if it exists and is a regular file, and so on and so forth. So you actually have this ability to build pretty robust if statements that can check a lot of information out about a file. You can even check to see if a file exists and is owned by a certain user. So once you start to think about the different ways that you can combine these file operator checks or file, basically checks on files on your operating system, you can really start to think of some neat ways to utilize that if statement in your scripts. This is just really touching the surface of what you can do with shell scripting, and my goal is to try to keep this really tightly scoped. So we're not looking at everything you can do with shell scripts here. We're just kind of starting to touch the tip of the iceberg, and in a future video lecture, we'll start to dig a little deeper into what is essentially the limitless topic of shell scripts.